The F-35 is the most powerful, most advanced fighter jet in the world today.
My favorite thing about flying the F-35,
F-135 jet engine.
It is really awesome, but not only that, it's reliable, it's safe. The maintenance on it is improved over other aircraft that we've seen.
The most powerful operational fighter jet engine in existence
would be honestly the motor. I go by a call sign of shock.
The world's most expensive jet engine is worth 10 Ferraris and more. At nearly $15 million a unit, the Pratt Whitney F135 is more than a piece of machinery. It's the beating heart of the F-35 Lightning II, the most advanced fighter jet ever built. This engine delivers insane thrust, enables vertical takeoff, and somehow still keeps the jet invisible to radar. But how? How does it stay stealthy while generating heat that melts carrier decks? How can a single engine design power 3 different variants, including one that hovers like a helicopter? And why did its rival engine get cancelled despite billions in investment? Stay tuned, as this story isn't just about warfare anymore. It's about politics, military dominance, and technology pushed beyond the limits. Subscribe for more insights into military aviation and aerospace tech. Also, buckle your seatbelts, because this story is just getting started. Now let's rewind the clock to the engine that came before it. You see, there was a time before the F-135 when stealth fighters still flew above and ruled the skies. Jets like the F-22 Raptors were beasts in their own right, and the machines that powered those beasts were equally magnificent. The F-119. This engine gave the Raptor its agility, supercruise capability, and stealthy profile. Back in the late 90s, it was everything. But here's the catch. The F-119 was designed for one mission: air superiority. It wasn't built for versatility. No carrier launches, no vertical takeoff, no global plug-and-play platform, just pure dogfighting dominance. That was fine in a Cold War mindset. And just a decade later? Well, not so much. Therefore, the Joint Strike Fighter program was born, an initiative to replace the aging fighter fleet. The hope was to build a single aircraft that could do everything: air-to-air, air-to-ground, vertical landings, stealth missions, you name it. And to power this impossible aircraft, they didn't start from scratch. They took the F-119 core and rebuilt it into something far more extreme. This is where the F-135 begins. It was part Frankenstein, part genius. Engineers added more stages, increased thrust, and integrated stealth cooling in ways no engine had attempted before. And for the F-35B variant, a lift fan system was installed that let the jet hover like a helicopter. Though midway into development, the program hit a wall. We're talking about major issues like extreme temperatures, component failures, and stealth coatings that couldn't handle the heat. It pushed material science to its limits. And some say the F-35's entire reputation was hanging by the engine alone. But while this was happening, something else was brewing. An alternate engine, developed by GE and Rolls-Royce, was quietly gaining traction. Lighter, potentially more fuel-efficient, and designed to outperform the F-135 in key areas, the F-136 posed a very real threat. But despite being brilliant on paper, it was quietly killed. Billions were spent on funding, the prototype was almost complete, and yet, the project was abandoned altogether. Did politics seal its fate? Or did the F-135 actually win on merit? That's where we're going next. The F-135 was supposed to be the chosen one. Built off the reliable F-119, it was engineered to be a global fighter jet that could do everything. But as the jet took shape, the engine started falling apart. Literally. Temperatures spiked beyond anything Pratt & Whitney had tested. thermal coatings began to fail, internal components cracked, and in the case of the F-35B, which is the vertical lift variant, engineers discovered the exhaust was so hot it could melt carrier decks. Let that sink in. The engine was so powerful, it was destroying the very platforms it was meant to launch from. And stealth? That added even more complexity. The F-135 had to stay cool and invisible. But high heat is the enemy of stealth, as infrared sensors can detect jets from miles away. Every time they fixed one problem, another popped up. The Pentagon got worried. Congress was watching, and critics were circling. And then, in the middle of this chaos, another engine appeared, the F-136. Co-developed by GE and Rolls-Royce, the F-136 wasn't just an alternative. It was a direct competitor. On paper, it looked like a winner. Lighter than the F-135, better thermal management, lower life cycle costs, more modular, and easier to maintain. It even had afterburner improvements that hinted at longer range and higher efficiency. At one point, it was said that the F-136 could outperform the F-135 in nearly every metric that mattered. And yet, it never made it to the skies. Despite billions in funding and nearly a decade of development, the F-136 was quietly killed in 2011. Why? Officially? Budget concerns? Redundancy? Streamlining? Unofficially? Well, that's where the story gets murky and political. The F-136 was late, over budget, and worst of all, redundant. Congress had to choose: fund 2 engines for 1 jet program, or bet everything on one. The result? Billions in development were written off, and the F-136 died a quiet political death. Some say it was about control. Pratt and Whitney used their decades-old influence. Others say it was just logic. But make no mistake, the F-135 didn't just win, it survived. And here's why: it wasn't just powerful, it was modular. One engine had to fit 3 very different aircraft. The F-35A, your classic runway fighter, the F-35B, a hovering beast for Marines, and the F-35C, optimized for carrier launches and long-range Navy missions. The F-135 had to be adaptable, smart, quiet, cold, and furious, all at once. That's like building one engine that powers a motorcycle, a submarine, and a spaceship, all in the same week. And now, let's ask the question no one dared to answer. What secrets are hidden inside the most expensive jet engine in history? And how does it disappear from radar while glowing like a star? The F-135 isn't just powerful, it's a paradox. Its engine burns hotter than any fighter jet engine before it, yet the jet still manages to stay cold to enemy sensors. An engine that pushes out 40,000 pounds of thrust, but leaves a minimal radar and infrared signature. That shouldn't be possible. So, how does it happen? Let's crack open the beast, carefully. To understand its secrets, you have to look at 3 key technologies. First on, the advanced materials. You know, F-135 runs so hot, every day, conventional alloys just wouldn't survive. We're talking about temperatures exceeding 3,000 degrees Fahrenheit. So, engineers had to invent metal that behaves more like a diamond lattice than a car part. We're talking titanium alloys in the fan blades, single crystal turbine blades that can handle temps above 3,600 degrees Fahrenheit, and composite shrouds designed to block radar like an invisibility cloak. These materials don't just resist heat, they laugh at it. But how do you cool an engine that gets hotter than lava, while still keeping it stealthy? We'll get there in a moment. Now let's talk about brains, because the F-135 isn't just a brawny engine. It's smart, very smart. It's integrated with the F-35's flight computer, thermal management, and even stealth management systems. This isn't just about thrust anymore. It's about situational awareness. The engine and airframe work like a symbiotic organism, which means adjusting airflow, cooling sensors, managing noise, and even redirecting heat away from vulnerable surfaces. If the F-22 is a fighter jet with a computer inside it, the F-35 is a computer that happens to fly. Another secret? The lift system. This is where things get wild. The F-35B, which is the Marine Corps version, doesn't just take off like a jet. It levitates like a Marvel character. That's because engineers added a vertically mounted lift fan connected to the main engine with a drive shaft and clutch system that could rival a Formula One car. The engine pushes hot exhaust downward. The lift fan pulls cold air upward, and side thrusters balance the whole thing like a gyroscope on a high wire. All of this is controlled in milliseconds, automatically by software. It's the difference between firing a rocket and balancing a pencil on your finger during a hurricane on a moving boat. But that flexibility comes at a cost, literally. Which brings us to the next big question. Why does this thing cost $15 million a pop? We're going there next, and the answer might just change your mind about what expensive really means in military tech. So, $15 million for one engine. That's not a slip of the tongue. That's more than a Lamborghini fleet, more than a space launch, more than an entire small-town fire department. So what makes the F-135 worth its eye-watering price tag? Let's start by answering what we left hanging. How do you cool an engine that burns hotter than molten lava and still stay stealthy? Answer: you don't just cool it, you hide the heat. The F-135 uses a trick borrowed from the world of Black Ops: thermal masking. Pratt Whitney created a cooling system that gave life to the stealth abilities of the F-35. Instead of simply venting out the white-hot exhaust, the F-135's nozzle mixes it with cooler bypass air to reduce its infrared signature. It's like taking a pot of boiling water and pouring in ice cubes. Not to cool the pot down, but to make it look cooler to heat-seeking missiles. Kind of like putting liquid nitrogen around a pizza oven. Then there's that wild design on the exhaust, sometimes called the turkey feathers. 15 overlapping flaps at the nozzle edge disrupt the airflow and break up the heat like a stealthy diffuser. The effect? A smudged-up fingerprint that's harder to read. This doesn't just reduce visibility to radar, it muddles the jet's heat trail like a getaway car leaving no tire marks. But here's the catch. This kind of adaptability came at a price: complexity. And that complexity led to some very real controversies, including breakdowns, budget brawls, and heat signatures that literally scorched carrier decks. Remember that brain we talked about earlier? It's making real-time decisions about power output, cooling, stealth management, and even sensor integration. It's not just an engine, it's a data node. And that costs big time. The result? While a Rolls-Royce Trent 1000 engine for a Boeing 787 costs around $10 million, the F-135 hits $14 million. For a single-seat warplane. But how does this engine affect the rest of the world? Allies use it. Enemies study it. And some countries? They're not happy about it at all. That's where we're going next. Because the F-135 isn't just a marvel of engineering. It's a global weapon. And not everyone's thrilled. The F-135 isn't just an American engine anymore. It's a diplomatic statement, a billion-dollar export, and, to some, a symbol of military monopoly. Right now, the F-35 flies for more than a dozen nations, from the US and UK to Japan, Australia, Italy, Norway, the Netherlands, and more. If you're a NATO ally with a modern air force, you've probably either bought into the F-35 or seriously thought about it. And with that, you're buying the F-135 too. whether you like it or not. And those breakdowns, delays, and even scorched flight decks we talked about? Yeah, that's not clickbait. In the early days, the engine ran so hot that it began blistering the protective coatings on aircraft carriers. It forced redesigns on both the aircraft and the decks they landed on, like trying to land a welding torch on a yacht. Meanwhile, spare parts became a nightmare. Some countries waited months for components. Software glitches delayed missions. Even minor upgrades became major budget fights. In 2021, the Pentagon found that 56% of F-35s couldn't fly at any given time, largely because of engine issues and sustainment problems. And the global users? They noticed. If you're going to fly the most advanced fighter in the world, one Royal Navy officer quipped, it would help if it wasn't in the hangar half the time. Still, most stuck with it. Why? Because, even with all its problems, nothing else comes close. So, how do global politics, allies, and enemies interact with the F135? Short answer? It's complicated. Countries like Turkey were kicked out of the F-35 program over political tensions, which meant no F-135s either. Yet parts of the engine were still being manufactured by Turkish companies, at least for a while. China, meanwhile, has been studying the F-135 obsessively. Their J-20 stealth fighter, often called the Mighty Dragon, has been compared to the F-22 and F-35, but it's widely believed to be underpowered by comparison. The WS-15, their attempt to rival the F-135, has faced repeated setbacks. One defense analyst joked, "China's jet can look like the F-35 all at once, but under the hood, it's still running Windows XP, Russia's Su-57, also struggling with engine development. Their second-stage Izdeliye 30 engine might approach the F-135's thrust levels, but with none of the stealth features and all of the maintenance headaches. The F-135 isn't just a power plant anymore. It's a power move, but the cost is not just in dollars, not anymore. Can an engine this advanced ever be maintained affordably across a global fleet? Or will its upkeep become its Achilles heel? Because buried inside this $15 million machine are plans, upgrades, growth potential. A new version is already on the table. And what it could do next? It might redefine what jet engines and warplanes are capable of. That's where we're headed. So, is the F-135 worth it? It's a question defense analysts, taxpayers, and even pilots have been asking since day one. Because let's be honest, $15 million is a staggering price tag. Still, majority justifies it because it goes vertical, it goes stealth, it goes global. But can this engine ever be maintained affordably across a global fleet? Well, that's where things get interesting. Pratt Whitney has already rolled out plans for the F-135 engine core upgrade, a major refresh to improve power, durability, and efficiency. It's not just about fixing problems, it's about future-proofing the jet for decades of service. This upgrade, dubbed ECU, adds thermal margin, boosts thrust, and opens the door for Block 4 capabilities like better sensors, weapons, and computing power. Maintenance, too, is getting smarter with AI-driven diagnostics and modular parts that can be swapped like Lego bricks. Will it bring the costs down? That's the billion-dollar bet. But make no mistake, the Pentagon is all in, so is this the final form or just a stepping stone? It's not the end, not even close. Behind the scenes, engineers are already working on next-gen systems. Whispered terms like adaptive cycle engines and variable bypass ratios are floating around. Sci-fi sounding tech that allows an engine to switch between fuel-saving and war-fighting modes on the fly. GE's XA100 is the front-runner in this category, and if adopted, it could leapfrog the F-135 with 30% better fuel efficiency and 20% more range. We're talking about jet engines that think, adapt, and morph depending on the mission. The F-135, then, is both a masterpiece and a stepping stone. a symbol of where we are and a glimpse of where we're headed. So, yes, $15 million sounds absurd. But now you know the answer. What do you think about this engineering marvel? Let us know in the comments below.